Hello everyone, welcome to the session. So now in this video, we will talk about MSE versus MAE in linear regression. I know that you are not aware about these words which I'm talking about, but I'm pretty sure that you have watched the previous video and you are already aware about the concept of error or residual in a linear regression, right? So what we have understood so far in the last session that we want to reduce that error. Uh, if you remember, that is what I have denoted in the last session, that we want to reduce the error, which I call it as a residual also. Error, or you can say a residual also, right? Which is the difference between the actual and the predicted value, right? Summation of I equals to 1 to n, yi cap minus yi whole square, right? This is the error term which we want to reduce. Now, this is also known as, in linear regression, called as a cost function or a loss function of linear regression. Always remember. Because this is a kind of a function which we want to reduce at any point of time, right? So this is called as a cost function or a loss function. And what is our target is? Our target is to reduce this cost function, loss function, or the error or residual via the gradient descent algorithm. Now, in the gradient descent algorithm, we have understood that, we need to update the value of m and c, and we have seen the formula for updation part, that a new value of m is nothing but the old value of m minus the learning rate into the derivative of error or the loss function with respect to the value of m. And similarly, the value of new c is nothing but is equals to the value of the old C minus again learning rate into the value of error with respect to C. And we have tried to evaluate the value of error with respect to M and with respect to C, right? If you remember, we did the derivation of getting the value with respect to C, and we got the answer as summation of I equals to 1 to n yi cap minus yi into 2, and derivative of e with respect to m, we got it as again I equals to 1 to n yi cap minus yi into the value of x of I into 2, right? This is what we will be able to get in the last session. You can just check it out. This is the value which we are getting, right? Now, this cost function or this loss function or this error can be either in the form of MSE or in the form of MAE in linear regression. What is the meaning of that? When I'm saying MSE, the simply meaning is mean squared error. So this part is something which is a component of a mean squared error. The only difference is because we're taking a mean, means the average. What you have to do is, we'll take it as 1 upon n. So this is the general error, which is the gap between the actual and the predicted, which I always say. But we usually take the value of MSE or MAE as the error function, right? When I'm saying MSE, full form is mean squared error. Now, as you can see, a squared term is coming up, means we have to square the values of the gap between the actual and the predicted. So the formula will come out to be summation of I equals to 1 to n yi cap minus yi whole square, and we will do the division by n, right? This is something which you can say is a mean squared error, because here we are trying to do a squaring, and after that we are trying to get the mean. So that's a division by n, right? Similarly, there is another error function which you can represent in the algorithms depending upon the situation. Now, what kind of situation I'm talking about, I'll try to explain that as well in the later part of the video. But as of now, just try to understand the difference between MSE and MAE. This can also be asked from you in an interview as well. This is called as mean absolute error. Mean absolute error. Now here, if you will observe, in both the cases, we are talking about error term only. Whether it's a part of a MSE or it's a part of a MAE, both are the components of the errors itself. So when I'm talking about MAE, mean absolute error, so there what we are trying to do is, again, we are trying to see summation of I equals to 1 to n, the absolute value of the gap between the predicted and the actual. And again, because we are trying to find out the mean value, so there will be a division by the value of n. So what is happening in both the cases? In both the cases, because we are focusing on the mean part, in the full form you can see mean, average. So we are doing a division by n, where n indicates the number of observations that we have in our given data set, and the difference only we are trying to evaluate. But in case of a mean squared error, we are doing a squaring of the difference. In case of a mean absolute error, we are just taking an absolute value of the difference between these two terms. Okay. Now the question is, as I told you, that in terms of error, we usually prefer to take either MSE or MAE. So if you will take MSE, your statement will look like now this, 1 by n. So that's why you will be able to get the derivative. If you will do the derivative, you will be able to get this kind of a statement. 2 by n, summation of I equals to 1 to n, yi cap minus yi with the derivative of e with respect to c. And when I'm saying derivative of e with respect to m, in that scenario, it will be 2 by n into xi. Again, the difference between the yi cap and the value of yi, where you know that the value of yi cap is the best fit line, which is equals to mx plus c, where m and c is the most optimal values, where the error rate is approximately equals to 0 with the help of the gradient descent approach. That's what we want to achieve, right? So that's the overall idea behind the difference between MSE and MAE. Now the question is that at what point of time I should consider MSE as a error term, and at what point of time I should consider MAE as the error term in my linear regression algorithm, or in any other algorithm also. See, whatever concepts I'm teaching you here with respect to the cost function, with respect to the error values, these similar concepts are equally valuable in other regression algorithms as well, which we will study in the later part of the videos, right? So the question is that if suppose interviewer will also ask from you that at what point of time, you will consider MSE as an error rate, and you will do the differentiation of MSE value with respect to M or C, and at what point of time you should prefer MAE? The answer will be that if at any point of time your data set contains too many outliers. Now, I hope you all have the idea of what do we mean by an outlier in a data set. So what I'm saying is, usually what happens that whenever we are trying to do a model training part, where we will try either linear regression or any other algorithm that we have, what usually happens before that, we usually do a EDA task, right? Exploratory data analysis. Exploratory data analysis. I hope you also have done the same, right? Now, what usually happens in this particular part itself, we will get to know that how many number of outliers are available in my data and how we can deal with them. Let's say if there are too many outliers, if the outliers are very less, maybe we can have an option of simply remove them. What is the meaning of outlier? It's a, you can say, exceptional value which is available in a complete data set. Okay? With the help of a box plot, usually we will try to check it out that what are the outliers available, and accordingly we will try to see how we can deal with them. For example, I will give you a very simple example. Let's say I will say that, do the analysis of the people working in Bangalore having a position of data scientist, and check it out on a monthly basis how much they are earning. Okay? How much they are earning. Maybe for a freshers itself I'm talking about. Okay? Now, let's say I went to different companies, and I got an idea that some people are getting 50K as a salary. Some people are getting 1 LPA after the tax deduction. Some people are getting 2 lakh, not LPA, 2 lakh, 1 lakh. Some people are getting maybe 80,000. Some people are getting maybe 1 CR. Now, if you will be able to observe, these values are somehow not that much, varied as comparable to this particular value. So I can say that this is an outlier with respect to this complete data set that I have. And with this outlier, if I'll take the average of all these terms, if I'll say what is the average salary of a people working in Bangalore as a data scientist position, with the help of this outlier, my average will drastically increase, right? So that's why it usually said that when outlier is available, take the median of a data, not the mean, because mean will impact more. Median is more robust to outlier. Similarly, when you have more data points available as an outliers, always and always go for MAE as a error function or the loss function, because MAE is more robust to outliers. It is more robust to outliers. Why I am saying so? Because you can see that the in MAE we are just doing a difference, whereas in MSE we are doing a square of that difference, which will become a very huge quantity, right? So maximum cases we are referring MSE only because it's really helpful for us in case of a derivative as well, because it's a power of 2. So it's very easy for us to do the differentiation also in the gradient descent approach, right? It would be really helpful. So maximum number of times you will see that almost in every scenario we are using by default MSE only. But in rare scenarios, just like just now I have discussed that in a given data where we will be having more outliers, MAE is the best choice as comparable to MSE. So, if someone will ask you out of MSE and MAE, which is more robust to outliers, your answer should be MAE, because it is just doing a gap or difference of that. Absolute difference it is taking up. But when we're talking about MSE, it is taking a square of that as well, which is a very big term, which is a very huge term, right? So, that is the overall idea behind the cost function or the error function that we have in linear regression, and the difference between the mean square error versus the mean absolute error that we have in a linear regression algorithm. And specifically, it's not in a linear regression, as I said, that in the upcoming regression algorithms also, same concepts only we are using. So in future, wherever you will see that we are taking a value of yi cap minus yi whole square, just do the divide by n also, because we are usually taking this as the error, where we are doing a MSE. We are taking a MSE as an error rather than taking a simple subtraction of the values. Okay. So I hope that now this is pretty much clear to everyone, and now everyone knows what is the meaning of a cost function, what is the meaning of a loss function, what is the meaning of an error, what is the meaning of a residual. All in all, they are the same things, but the naming is somewhere different, right? So in future, if someone will ask you these questions, don't get confused. Okay. So with this, let's end today's video. I will see you all in the upcoming video, where now we will discuss further interesting concepts with respect to linear regression algorithm. Bye bye everyone, and see ya.